大家好哈，我想休息了一下子，现在应该比较有精神，比较有活力，来再继续下面的 topic。那接下来我们会请陈先生来跟大家讲一下这个主题，谢谢。
喂。And hello, I'm Chen. Thank you for coming. Today I want to talk about an experimental project named Mohohan. Mohohan is a cloud transcoding services implementing with Apache Hadoop and some of Amazon Web Services such as S3 Simple Storage Service and Elastic Compute Cloud EC2 and Elastic MapReduce EMR. And of course, GNU and GPL license freeware named FFmpeg are used. This is the outline. And I'm going to talk about the importance of online transcoding services in the first section. And then I'll bring you some background knowledge of Apache Hadoop and some AWS services I used. And then in the data flow section, I will show you how I merged the previous concept into the bird-eye map. And with some currently relevant services in some third-party standards. And maybe I could demo this little project after that. This is my info. I've passed 2 of the Cloudera certifications in Apache Hadoop, and both administrator and developers. So if you have any question about this little project, you can email me after this speech. Okay, before I start, I want to ask you a question. How many people have a smartphone? If you have a smartphone, raise your hands. Sounds like most of you have smartphone. Most of people have smartphone with some social apps, such as Facebook or Twitter and something else. Seriously, what will you do if you buy one smartphone first? For me, I will take a photo. So, not only taking photos, but after you take photo, you will publish onto the Facebook or something else social apps services. The smartphone causes the information explosion in not only the textual way, but also multimedia. We share photos, we share movies every day, and some side effects may occur. Online movie clips become massive and in different formats. Some of them may not perform good in online streaming. So, an online cloud transcoding service will provide a visible solution to this issue. And of course, every cloud computing services, not only transcoding, every cloud computing services should face this problem. How to find a half-point way between temporal and spatial issues. Now I introduce the background of the Apache Hadoop. There are 2 main concepts of Hadoop: a distributed file system and a programming framework. First, HDFS is the yellow cube in the figure, which stands for the file system. You can imagine those 2 cubes actually stand for one file system named HDFS. The second, MapReduce, it is not the blue square, Actually, it is a function run of the blue square. The blue square stands for a single machine, and those squares stand for a computing cluster. In this figure, Hadoop provides a container named HDFS to store your massive files, and call a function named MapReduce to pull your files out of your HDFS and process them and put the result back to your HDFS. Since Mohohan is an online service, I need to access it every time and everywhere. So I need an online web services to let me implement Apache Hadoop and let it never stop. So that's why I'm using AWS. I first introduced AWS S3. The full name is Amazon Web Services in Simple Storage Service. Remember the previous figure? Can you imagine? S3 is another kind of HDFS. So I use the same yellow cube to stand for it. It is an online distributed file system which never shut down. And it is the bucket item infrastructure. That is, in this file system, folder never exists. It is a flat file system. Now I'm introducing AWS EC2. The full name is Amazon Web Services in Elastic Compute Cloud, or you can just call it a virtual machine. In previous, it provides the physical computational resources and an operation system to handle these resources. That means you specify the function in each EC2, and the EC2 will run those functions as your wish. So how about I put the function follow the Hadoop framework and let EC2 work for me? Can it be done? Of course, yes. This blue square is just like the figure in page 5, stands for a single machine. Now, I'll introduce AWS EMR. The full name is the Amazon Web Services in Elastic MapReduce, or you can call it an Amazon version Hadoop. Actually, it is a cluster of EC2s with well-prepared Hadoop environment settings. In the figure of page 5, each component could map into an AWS services into this figure. So S3 stands for HDFS, and EC2 stands for a task tracker or data node in Hadoop. And the cluster of EC2 named EMR stands for Hadoop clusters. So the EC2 get data in your specified S3 and process them and put the result back to your S3, which is another kind of HDFS. This is how Mohohan works. Let's talk about Mohohan itself. This figure shows the whole methodology of how a big movie be transcoded into a small one. Mohohan first launched EMR and pulls the movies from S3. Then Mohohan divides the movie into two parts, the video part and the audio part. And then Mohohan splits the video part into chunk of frames. So the input of Hadoop is the chunk of video frames and the audio part of movies. After the processing of Hadoop are the small pieces of chunk of frames and small pieces of audio part. Then Mohohan merged these two parts to a small movie clip and store it back to your S3. This is the splitting page. When I'm When I do this project, some people ask me, why don't you just directly split your movie into a small movie clips? You don't have to split the movie into video and audio stream. It is so difficult. Why? Why you do that? The answer is, if I do like this, I will receive the discontinuous audio stream. As you can see, this script, it is written in shell script. I pull the movies from S3 and split them into audio and video chunks. The tools I use are FFmpeg, which I mentioned before, and another MKV merge is another GNU and GPL licensed freeware. This is the transcoding stage. I use file name to distinguish the video and audio parts and process them separately. In the FFmpeg comment, you can see I use two-pass transcoding, which is suited for online video streaming. The video and audio format are H.264 and AAC, which is the same from the benchmark settings in the benchmark section. This is the merge stage. This stage is quite simple, without any skills if you are familiar with the shell script. I'm written in BA shell, BASH. EMR merge all results from EC2 and merge them into a final transcoded movie and put it back to your S3. Then shut down all the EC2. The whole job done. Then you may want to know how fast it can be. So I find a third-party benchmark report sponsored by ThenCoder in the last year. ThenCoder is one of my competitors. The link of whole report, including the data set, transcoding format, and benchmark metrics, will show in the next page. I just give you a brief in this slide. Mohohan will compare with 4 online transcoding services, including ThenCoding, and Sourceon, and Panda. I've used Avatar movie trailer download from apple.com, which is the standard data set mentioned in the benchmark report. So table 1 shows the info of this movie, and table 2 shows the transcoding argument of each services, including Mohohan. Mohohan has additional parameters to specify how many EC2s I use to transcode and how many physical resources of each EC2s, such as CPUs, memories, and I/O transcoded. This is the result. The blue bar stands for the average transcoding time, and the blue bar plus the red bar stand for average total execution time. You can see Mohohan performs best in the transcoding time of overall competitors. It is nearly half of the total duration of the movies. But however, it costs much more time in EC2 initialization time. It is the cost of the long red bar. This is because EMR needs time to start the EC2s, waiting for bootstrap, installing some essential software, and apply the Hadoop settings. But fortunately, this issue could be solved if we provide a well-setting EC2 image and made it keep running. Now, it is the exciting part. Mohohan could make it faster if I launch 20, 30, or even 100 EC2s in the same time. So to transcode a Blu-ray or a 3D movie will become easier someday. Now, I give you a demo. As you can see, I put the movie files on S3 and call Mohohan to grab it and process and put it back to the S3. The original link is here. It is access denied because it is never provided. It is just processing. You can see the pre-running is the start initialization of each EC2 and EMR. This page will refresh each 10 seconds. So before, at about 2 or 3 minutes, the total job will finish. And in the same time, I will bring the Q&A section in this time. And thank you for attention. Okay, if you have any questions, you can ask it now. Now you can see this project is running. And after it running, this file should exist with the transcoded file. This link is the benchmark.请问各位对于这个议题有什么样的问题吗？
不好意思，请问一下，我刚才搜寻一下 Mohohan 这个 project， 可是没有在网络上有看到 Mohohan 这个 project 的那个 offshore 的那 website， 所以第一个就是你这个 Mohohan 这个 project 有一个 offshore website 在网际网络上面可以去执行或者其他的可以取得吗？这是第一个。那第二个，我们看到那个 media URL 的部分是用 S3 开头，那就会想到一件事说，那它在 parser 的时候是可以直接 parser 像 YouTube 或者是一些 online 的 video， 然后去做就是 live encoding 吗？然后第三个问题是说，什么样的 media type 是它所 support 的 media type？ 比如说，我刚刚看它上面的，因为刚才看你的 slide 上面是看到它把 video 跟 audio split， 然后用 Hadoop 去做 MapReduce， 然后去做运算嘛 ？OK， 是。那是所有的现在的 multimedia 的 type 都 support 吗？还是说因为你用的是 FFmpeg 的关系，那是不是有一些 type 是不 support 的部分这样子？谢谢。
第一个问题是这有没有
对，
官方网站？
对，因为刚刚在 Google 上搜寻 Mohohan 好像找不到。
就这个计划呢，是之前的公司就是叫我私人制作的，所以它并没有官方网站。
OK。
它的网站名称就是在 slide 里面。
OK。
对，然后因为它只是一个工具，就是公司内部的大量影片在做转档使用。
Yeah。
然后第二个问题呢，它是不是只能 parse S3 的 URI？
对。
那这个部分呢，是因为当初写程式的时候是只写它可以吃 S3 的 URI。因为之前我在用的那个 shell script， 我使用的是 S3CMD 这个工具，它能抓的那个 URI 就是 S3 的 URI。当然呢，如果你把档案放在 S3 上面，又希望能够用 HTTP 的 URI 的话，你可能第一个必须要把它的权限，就把它的 ACL 权限开成 publish。然后有一个很重要的一点，是因为 Mohohan 会去你的 S3 抓资料，也会把处理完的资料丢回你的 bucket 里面。所以你必须要把你指定的那个资料夹，或者是你指定的那个 bucket， 要有权限开成让 Mohohan 的账号可以去读写，要不然资料会写不回去。那最后一点就是它支援的那个 file format。好，我们现在是使用 FFmpeg 嘛，然后里面所有的所支援的 codec 都是要自己编译的。对，所以说，如果你想支援不同的影像或声音的 codec 的话，可能也要自己先下载 resource， 然后再来编译。像 Mohohan 所使用的那个 FFmpeg 就是我自己编译的，对，它有支援 AAC 跟 H.264， 就这两种，所以自由度基本上是非常高。那这样算是有回答到你的问题吗
？OK， 谢谢。
谢谢。哦，对，那这个影片应该已经好了，所以现在如果再点同样的连接，就会是有东西的。像 online streaming 就有一个好处，就是你如果跳到任何一点呢，就是可以从那个点直接播放。这也就是为什么要分 two pass transcoding 的一个问题，就是你从任何一点继续播放的话，那这里为什么不能播放呢？大概是因为就是自己的口袋的问题吧。对，总之转档好的就是你的档名，然后后面点 MP4， 就是转档好的档案会丢回的地方。好，这大概就整个 demo。然后时间的话，就大家看到209秒，跟刚才的那个时间是差不了多少的。然后花在转档的时间比较短，但是花在 presetting 跟 postsetting 的时间会比较长，就是因为 EC2 需要开机与关机，还有就是线上安装一些。本来就线上要安装一些类似 FFmpeg 这些软体，因为 EC2 刚开机的时候还是空的，就你还没有装任何东西，所以它自然就不能转档。那因为时间还很多，今天的报告比较短一点，那不知道各位还有什么对于这个专案有一些其他的问题吗？
不好意思，我想问一下，有测试过多大的档案？
我有测试过那个《决战异世界》的蓝光光碟影片，转档的时间也是1:1的时间。
那请问，在转比较大的档案的时候，它的效能会有落差吗？
转大档案的时候，效能有一个比较大的瓶颈，在于传输上面，因为蓝光光碟它是每1秒的 frame 呢，可能会有30到40 MB 这么大吧，就有点不太清楚。然后，但是在转档之前呢，我们除了要把档案从 S3 抓到本地的 Hadoop cluster 里面，还要先把它放到本地的 Hadoop cluster 的 HDFS 上面，然后再让所有的 data node 把档案抓下来，转档，然后再推回 HDFS， 然后再由某一个 master node 把 HDFS 里面的所有转档好的再拉下来拼起来，所以会花很多的 effort 在大档案的转档上。但是它的好处就是，在传输大档案，其实只要一次就是传上去，因为转好的档案是小的，所以它目前一个算是很大的瓶颈。它可以用什么方式解呢？它可以就是靠着你一次如果开很多的 instance， 那就会分散档案上传的速率。那不知道这个有没有回答到您的问题吗？有吗？谢谢。